In this video we're looking at concentration and chemical reactions, and this is where you need to apply your concentration formulae to solve problems associated with chemical reactions. And you might be finding the concentration of a product in an aqueous reaction or the volume of mass of a product of a certain amount of solution is reacted. And because these are applying our moles laws to our equations, we use the demon sword technique again. Data equation moles, ratio, number of moles of species 2, substitute answer units, and then double check. So let's look at the questions we have for example 20 to teach us how to use or to solve these sort of questions. The first one is calculating the concentration of sodium sulfate if you mix some sodium hydroxide with the sulfuric acid solution. And the second question is about finding the volume of hydrogen gas if you react some hydrochloric acid with magnesium. So looking at this first question here, calculate the concentration of sodium sulfate in the final solution if a certain concentration and volume of sodium hydroxide reacted with a certain volume of sulfuric acid. So if we look at this model again, in this sort of question, we've been given something about species 1. We know the concentration and volume of sodium hydroxide. So that's our clue. We've got to find the moles of species 1, which in this case is sodium hydroxide. We need to write down some sort of chemical reaction and convert the moles of sodium hydroxide to the moles of species 2, which in this case is sodium sulfate, via this mole equation. And now we've got the moles of species 2, we can then use this formula here because we're trying to find a volume or concentration of sodium sulfate at the end. So that's the technique we're going to use for this question. So first thing, D for data. What data has the question given us? Well, there's 4 things we're going to be thinking about: the concentrations and volumes. See if you can fill that data in. If you want to pause the video and see if you can fill that in. Okay, so the question's told us we're trying to find the concentration of sodium sulfate. The volume of sodium hydroxide is 200 mils, but don't forget we need to use litres in chemistry, so we've got to convert that to 0.2 litres. The concentration of the sodium hydroxide given to us in the question is 0.5 moles per litre, and therefore we put that in here. And the volume of sulfuric acid reacted is 500 mils. Once again, converted to litres gives us 0.5 litres. So what we do now is E, the equation. Now, I've made a note here, it's a complete reaction. So it says calculate the concentration of sodium sulfate in the final solution if the sodium hydroxide is completely reacted. That means we know all the sodium hydroxide is dissolved. So next thing, E for equation. See if you can write down the chemical reaction between sodium hydroxide and sulfuric acid. And hopefully what you got is 2 sodium hydroxide aqueous plus sulfuric acid aqueous turns to 1 sodium sulfate aqueous and 2 water molecules. The next thing on the list is, well, we've got a mole ratio there, 2 to 1 to 1 to 2. And we're going to find the moles of species 1. So see if you can find the moles of one species in that equation. Pause the video, we'll have a go at that. Hopefully what you found is you can find the moles of sodium hydroxide because you know its concentration and volume. So using moles equals CV, which in this case is 0.5 moles per litre times 0.2 litres, gives us 0.1 moles. We've got 0.1 moles of sodium hydroxide in here. Now we use our ratio. The question is asking us to find the concentration of sodium sulfate. We need to find the ratio between sodium hydroxide and sodium sulfate. So that ratio is number of moles of sodium hydroxide divided by 2 equals number of moles of sodium sulfate divided by 1. So to find the moles of species 2 in this case is moles of sodium sulfate. It's just going to be moles of sodium hydroxide divided by 2, which for us is going to be 0.1 divided by 2, which is 0.05. So we're ending up with 0.05 moles of sodium sulfate. The next thing the question is asked us to find the concentration of sodium sulfate. Well, concentration is number of moles divided by volume, but in this case the volume is the volume of the solution. So a little trick here, don't forget we're actually adding 2 volumes together. So see if you can figure out what the total volume of the solution will be, and hopefully you figured out the final volume will be the 0.2 plus the 0.5 litres, gives us a 0.7 litre solution. So now we can substitute our numbers in. So the number of moles is 0.05 divided by 0.7 litres. Now we can go to our answer and units. So I've got 0.0714. We can double check our significant figures as well at the end, which is 0.07. It's 1 significant figure, moles per litre. Now moving on to part B. This time they've asked us to calculate the volume of hydrogen gas produced if 25 ml of a 2 mole per litre hydrochloric acid is completely reacted with magnesium at 25 degrees and 100 kilopascals. So we've got lots of data about hydrochloric acid, and we're trying to find the volume of hydrogen gas, which means in our little diagram here, we know enough information about hydrochloric acid to calculate its number of moles. We've got the concentration and volume, so hydrochloric acid would be our species 1. We then need to write the reaction equation to find the moles of species 2, which in this case is hydrogen, because we've been asked a question about the volume of hydrogen. And that means down this path, because we can use this equation to find the volume of hydrogen. So that's our map through this particular question. So first thing, D for data. What data have we been given? So they're the things we've been given. We want to find the volume of hydrogen. The volume of hydrochloric acid is 25 mils or 0.025 litres. the concentration of the hydrochloric acid is 2 moles per litre, and the molar volume at 25 degrees and 100 kilopascals is 24.79 litres. So the next thing to do is E the equation, but just note it says the hydrochloric acid is completely reactive, so that means we know all the hydrochloric acid is used up, so this entire moles of hydrochloric acid has been used up. So what's the equation? See if you can pause the video and write down the reaction equation. Hopefully you found that 1 solid magnesium reacts with 2 aqueous hydrochloric acid molecules to produce aqueous magnesium chloride and hydrogen gas with a mole ratio of 1 to 2 to 1 to 1. So that's our D and E. The next thing is the moles of species 1. We've already said we've got enough data to find the moles of hydrochloric acid. Number of moles equals concentration times volume, which in this case is that 2 times 0.025 gives us 0.05 moles of hydrochloric acid. The next thing, our ratio, we're trying to find the volume of hydrogen gas. We've got to use this equation to find the ratio between hydrochloric acid and hydrogen gas. In this case, it is the number of moles of HCl divided by 2, because it's 2 in the ratio, equals the number of moles of hydrogen divided by 1. Or in this case, number of moles of species 2, hydrogen, is just going to be number of moles of hydrochloric acid divided by 2, which is 0.0512, which gives me 0.025 moles of hydrogen gas. The last thing, what's the volume of the hydrogen gas? So here we go, volume equals number of moles times the molar volume. So now we can substitute our numbers into there because we know the number of moles and we know the molar volume. It's just going to be 0.025 times 24.79 down to our answer in our units. Gives us 0.61975 litres, but now we've got to double check our significant figures. Looking at this question, we've got 25 mils here and 2 moles per litre. They're the two numbers we actually used in our calculations. It looks like one significant figure to me, so that answer comes down to 0.6 litres to one significant figure.